Welcome to the second part of our inverse functions podcast. In the first part, we looked at inverting functions when they were in an ordered pair form and at inverting a function when it was in its graphical form. In this podcast, we look at the third form of a function, the equation form, and we see can we form an inverse when functions are given in equation form. Let me just say that the process of inverting is a process of reversing something that has been done. Inverse is like reverse. We do that in our daily lives every day. Take an operation as simple as taking out some jelly to use to make a jelly sandwich. If we went to do that operation, we'd first open the refrigerator, we'd take the jelly out, close the refrigerator, and take the cap off the jelly to give us access to the jelly. Once the sandwich was made and we wanted to put all that jelly back, we would put the cap on the jelly, open the refrigerator, put the jelly in, and close the refrigerator. Now let's take a look at the differences between these two lists. Take a look at the first item in the first list, open the refrigerator. It is exactly the opposite of the last operation in the second list, close the refrigerator. Look at the last operation of the first list, remove the cap. It is exactly the opposite operation of the first operation in the second list, put on the cap. That is, when you reverse something, you do opposite operations in opposite order. Let's see if that would work for functions. In the function f of x equals 2x minus 3 over 4, remember that when you have a horizontal division line, there's this invisible parentheses around the top, so the first operations we would do would be the operations in the grouping symbol. So we would first multiply by 2, then we would subtract 3. The last operation we do would be the one out of the grouping symbol, divide by 4. Now suppose I just write down the opposite of those operations in the opposite order. In other words, if the first operation here is multiply by 2, I make the last operation here divide by 2. If the last operation here is divide by 4, I make the first operation multiply by 4. Opposite operations, opposite order. Let's see what a function would look like if we followed the steps of the opposite operations in the opposite order. We would be building f inverse, and the first thing we'd want to do is multiply x by 4. The second operation we'd want to do is add 3. And the last operation we'd want to do is divide by 2. Opposite operations in opposite order. But did we really build an inverse? That is, do the rules for constructing an inverse function obey the same rules as taking out a bottle of jelly? It doesn't seem like math would work that way, but maybe it does. Let's take a look at f composite f inverse of x. So what's going to happen, that's f inverse of x. What's going to happen is f inverse is going to change x, and then f is going to try to change whatever inverse changed x to back to x again. If it did, it's the inverse function. So let's give it a shot here. F dot f inverse of x means f of f inverse of x. And what is it that f inverse does to x? Well, f inverse takes x and changes it to 4x plus 3 over 2. So how would we find f of 4x plus 3 over 2? Well, we would just write f with empty holes. 2 empty hole minus 3 over 4. That's f right here. And then we'd put f inverse, the 4x plus 3 over 2, into the empty hole. Well, let's see what happens. The 2 cancels the 2. So we get 4x plus 3 minus 3 on the top, 4 on the bottom. The 3 minus the 3 zeros each other out. So we get 4x over 4. The 4's cancel each other out, and we get x. So f inverse took x and changed it to this very complex expression 4x plus 3 over 2, but f took the 4x plus 3 over 2 and changed it right back to the x again. So it is the case that when we did opposite operations in opposite order, we really did get the inverse of the function f. Now, Suppose, though, that the order is not clear in the formula. Take a look at this one. We have y equals 2x minus 3 over 5 minus x. What's the first thing done to x? Is x first multiplied by 2? Does x first get its sign changed? Does x first get added to 5? It's not clear at all what happens to x first. When you have a situation like that, and really even in the situation before where you were just trying to invert a simple function, we can go back to what we did with ordered pairs. With ordered pairs, we simply interchange the x and the y. Let's do that here, finding the inverse by reversing x and y. Instead of saying y equals, I'll say x equals. Instead of saying 2x minus 3, I'll say 2y minus 3. I'm simply reversing the roles of x and y, and if I do that, y should be f inverse. But y is all buried in here. We can't really see what y is, so can we solve for y? Well, sure we can. That's a very simple equation. It's just got two terms. The common denominator is 5 minus y, so let's get rid of the common denominator. Multiply this term times 5 minus y. Multiply this term times 5 minus y. And on the right side, we get rid of our denominator. Now we have the equation 5 minus y, x on the left, is equal to 2y minus 3 on the right. Now the next thing that we want to do is we want to get y out of the grouping symbol. So we write that as 5x minus xy equals 2y minus 3. And now we want to get our y terms to one side and our non-y terms to the other side. I could bring the 2y over here, but then both my y terms would have negative signs. So I'm going to move the xy to the other side. So on the other side, I'm going to get 2y plus xy. On this side, I'm going to bring the 3 over, so I'll get 5x plus 3. Now I want to form a single y term. So, continuing on, I'll call this 5x plus 3 equals 2 plus x y. There's a single y term, and now if I divide both sides by 2 plus x, they cancel on this side, and I get y equals 5x plus 3 over 2 plus x, and we said that y should be f inverse of x, so I'm just going to write here f inverse of x. Now the next thing we'd like to do is make sure that we really have the inverse. So what I'm going to do here is I'm going to take f inverse dot f of x and see that's going to be f inverse of f of x. Let's see if we get x again. First off, I need to know what f does to a number. And f, our original function, takes any number and changes it to 2x minus 3 over 5 minus x. So what does f inverse do to that? Well, f inverse takes a number and changes it to 5 times the number plus 3 over 2 plus the number. So I get 5 times 2x minus 3 over 5 minus x, 2x minus 3 over 5 minus x. To clear that complex fraction, I'm going to multiply top and bottom by 5 minus x. Then I get the expression I'm kind of cramped for time here, so what I've done is I've just shown you the last steps here. And you do get x, and you can go through those steps for yourself. Here you're distributing, of course, and you'll be distributing on the bottom as well. So see if you can finish those steps. You do get x. That is the inverse function, and that completes the podcast.